Okay, so this is 18.5, multiplication of radicals. Again, we're doing all these three notes together because they're all related. So looking at the concepts, multiplication property of radicals, the expression of the form n through a to the power of n, special case, and then how to multiply radicals with different indexes. So this first concept we already went over in the previous notes. This one is just saying that if we have the radical of a times b, we can give that radical to a and give that radical to b. So we can separate them. Okay. So looking at example 1, since we are multiplying two radicals together, that's the same as multiplying the outsides and then multiplying the insides. So for example, 3 square roots of 2 times 5 square roots of 6 is the same as saying 3 times 5 and then the radical 2 times the radical 6. So this is times the square root of 2 times 6. Okay. Then we simplify that. What's 3 times 5? 15. And what's 2 times 6? 12. So multiplying these two radicals together, we get 15 square roots of 12. However, this is not our answer because we have to see if the radical can simplify further. So we have to see if we could do the prime factor tree off of 12. So if we do the prime factor tree off of 12, we get 2 and 6. And then off of 6, we get 2 and 3. So that tells us that the square root of 12 is the same as writing 2 square roots of 3 because that pair of 2's go on the outside and then the 3 goes on the inside. So that means that 15 square roots of 12 is the same as 15 times 2 square roots of 3, which simplifies to what? 30 square root of 3. This is our answer. So when we are multiplying two radicals, it does not matter if the radicands are different. The only thing we're checking is the same is the indexes. So on number 1, they were both the square root, so they both had the same index. What about on number 2? Do we have the same index?
Yes.
Yep, since we have the same index, we're going to multiply the outsides and then multiply the insides. Okay, so on the outside, we have 2x times negative 7. And what do we have on the inside? Y times xy. So simplifying that, what's 2x times negative 7? Negative 14x. And what's y times xy? Good. Good, xy squared. Yep, xy squared. Can we simplify that radical of xy squared?
Yes. You can pull out one of the y's.
Correct.
Pull out the y's.
Yeah. So we would have negative 14x square root x square root y squared. That y squared and that square root cancels. So we have negative 14xy square root x. This is our answer because it's the most simplified. So once we multiply, we check if anything else can simplify. Okay, any questions so far? Okay, on number 13, do we have the same indexes? What's our index? 3. We have the same index of 3, which means we can multiply our outsides and then multiply the insides. So what's on the outside?
15 and 1/3.
15c, don't forget the c right there, and then times 1/3. Okay, what about the inside? Good, CD times CD squared. Okay, so simplifying the outside, what's 15c times 1/3? 5c, good, because that's the same as saying 15 divided by 3. So 5c, cube root, we have c times c. That turns into what? C squared. And then we have d times d squared. D cubed. Okay? So checking if we can simplify, I'm going to split up the radicals where one of them has the c's and one of them has the d's. Out of the c's and the d's, which one can end up canceling? The d, because we have cube root and we have the cube. So those cancel out. They're both 3's. So that means the d goes in the front. So we have 5cd cube root of c squared. That's our answer. So we're always checking to see if we can reduce what is under the radical. Okay. Any questions on number 3? What's different about number 4?
There's a 2 on the end of 11 on the first.
Good. So
Parentheses.
those parentheses right here is what's different. So if we have a term outside of the parentheses, that means we use what? What property? The distributive property. So this 3 times the square root of 11 is going to distribute inside the parentheses. Okay, so this is going to distribute inside the parentheses. And remember, another word for distribute just means to multiply. So we have 3 square roots of 11 times 2 plus 3 square roots of 11 times the square root of 11. Okay. How can we simplify this first part here?
3 times 2.
Good, we would do 3 times 2 because these are the whole numbers, right? 3 times 2, which gives us 6 square roots of 11. How would we simplify this second part?
Cancel out the square root, technically.
Yes, but there's a step prior. So if we have 2 square roots of 11, that's the same as writing the square root of 11 squared. So plus 3 square roots of 11 squared. And like you were saying, since we have the square, we have the square root, these end up canceling out. So we have 6 square roots of 11 plus 3 times 11. Okay. And what's 3 times 11?
33.
So we have 6 square roots of 11 plus 33. Can we combine these terms? No, because remember they have to have the same radicand. And 33 does not have any. Okay? So these are not like terms, so this is my answer as simplified as it can get. Remember, in order to add or subtract, they have to have the same radicand and the same index. So on number 4, we distributed. What are we going to do on number 5? This is a binomial times a binomial. We're going to FOIL. Remember, the FOIL method is we take the first term, so the square root of 5, multiply it in, and then we take the second term, 3 square roots of 2, and multiply it in. So we're going to end up with 4 terms. Okay. Showing my steps, I have square root of 5 times 2 square roots of 5. Okay, that's my first multiplication. Then I have the square root of 5 times negative square root of 2. Now I'm doing the other part, the part I did in blue. So then I have 3 square roots of 2 times 2 square roots of 5. And then 3 square roots of 2 times negative square root of 2. So this is me writing out that whole step before I'm going to start combining like terms. Okay. So starting off in the beginning, I have square root of 5 times 2 square root of 5. How can I write that? Good. 2 square roots of 5 squared, because there's 2 square roots of 5 being multiplied together. Okay, I'm going to simplify the rest of it in the next part. So we're looking at now this part. Square root of 5 times negative square root of 2. What is that going to become? Good. Negative square root of 10. So we're thinking back of our properties of our radicals. Okay. Third part, what is 3 square roots of 2 times 2 square roots of 5?
6 square root of 10.
Good, 6 square roots of 10. And then last part here, we have 3 square roots of 2 times negative square roots of 2. Correct. Negative 3 square roots of 2 squared. Okay. What's going to happen to the square root of 5 squared and the square root of 2 squared? Cancel. So we're left with 2 times 5 minus square roots of 10 plus 6 square roots of 10 minus 3 times 2. How can we combine negative square roots of 10 plus 6 square roots of 10? What would that become if we combine them?
5 square root of 10.
Good, 5 square roots of 10, because we have negative 1 plus 6, which is 5. Okay, so this is 5 square roots of 10. What about these outside numbers here? What's 2 times 5? 10. And what's negative 3 times 2?
6.
Negative 6. So then we can now combine 10 minus 6, which is 4, and then bring down that plus 5 square roots of 10. Okay. Do you think we could simplify this further?
Yes.
So if we tried to do the factor tree on 10, are we going to be able to simplify that? Because what would the factor tree on 10 look like?
No.
5 and 2, and is there any pairs? No, so that means square root of 10 cannot reduce, so this is our answer. Okay, but it's always good to check to see if your radical can reduce. Okay, go ahead and try number 6. This is going to be the same as number 5, so same steps. So you're going to be foiling. Okay, continue working. I'm just going to go ahead and write out that first step of foiling each term. Okay, so foiling everything out, that first step you should have wrote is negative 10a square roots of b times a square roots of b. And then negative 10a square roots of b times 2b, that's the first part. And then 7b times a square roots of b. And then 7b times 2b. So once you have that step of foiling, then we're simplifying here. So in the first part, that negative 10a and that a in the next part is going to be negative 10a squared. And then square root of b times square root of b is square root of b squared. So that's just for that first multiplication. On the next one, since it does not have that square root, that 2b is being multiplied by that negative 10a. So we have negative 20ab square roots of b. In the next part, we're doing 7b times the a because it's on the outside, and we're left with just that square root of b. So plus 7ab square roots of b. And then lastly, we have 7b times 2b which is going to be 14b squared because there's two of them. 14b squared. Okay. Which means we have that square root of b squared that cancels out, just turns to a normal b. So this is negative 10a squared b, okay, plus 14b squared, because I can't do anything with that 14b squared. And then looking at these terms here, they both have that b squared, they both have the index 2, and they both have variables a, b. So I would just do negative 20 plus 7, which is negative 13 ab square roots of b. Okay? This is my answer, because I can't simplify any further. Anybody got close? If you're able to get this step here of foiling and multiplying them together, then I feel like you're on the right track. Okay, any questions? Okay, number 7 looks a little different. Because looking at that second parentheses, how many terms are in there? 3. So we're still foiling. We're still foiling the binomial into a now trinomial. There's just going to be an extra set that we're multiplying. So for the first part, 2 square roots of x is going to multiply by each term inside. So this time there's 3 things that the first term is being multiplied by. Same with that square root of y. It's going to be multiplied by each of those 3 terms. So writing this out, I have 2 square roots of x times 6, that's the first term, plus 2 square roots of x times negative square roots of x, second term, plus 2 square roots of x times 8 square roots of y. So that's distributing everything in red. Now looking at everything in blue. So we have square root of y times 6 plus square roots of y times negative square roots of x plus square roots of y times 8 square roots of y. So we should have 6 terms now that we're going to be simplifying. So looking at the first one, 2 square roots of x times 6, the only numbers that are being multiplied are what? 2 and 6. So we have 12 square roots of x. Oh no. No. Disconnected. It just disconnected. Okay. So this next part is that 2 square roots of x times negative square roots of x. So that negative is being multiplied by the 2, so minus 2, and there's 2 square roots of x, so this is square roots of x squared. Then we have 2 square roots of x times 8 square roots of y. Okay? So combining this, we have 16 square roots of xy. I multiplied 2 times 8 and got 16, and x times y and got xy. Then I have square root of y times 6, so that's going to be 6 square roots of y. And then I have square root of y times negative square root of x, which is negative square root of xy. And then lastly, I have y squared times 8, or sorry, square root of y times 8 square root of y, which is going to give me 8 square roots of y squared. Okay. So going through this whole thing, just looking right now, I'm going to have two things that cancel. And what are going to be those two things?
Y squared, x squared.
Good. This x squared and then this y squared. So I have 12 square roots of x minus 2x plus 16 square roots of xy plus 6 square roots of y minus square root of xy plus 8y. Looking at all these, which are the only terms that can combine? Only like terms.
16xy and negative xy.
Good. This 16xy and this negative xy, which is going to combine to what?
15xy.
Good. So I have 12 square roots of x minus 2x plus 15 square roots of xy plus 6 square roots of y plus 8y. Looking at each of these terms, nothing else has anything in common. So this entire thing is our answer. In these longer problems, usually you're going to have longer answers because not all the terms are going to have like terms. Okay. Any questions on that first concept? The next concept we talk about a lot already in these problems, and that's concept 2, the expression of the form nth root of a to the n. All this is saying here is that if we have the square root of something and then we square it, what happens to those square root and squares? They cancel. So that means the square root of 11 squared is equal to 11. That's our answer. So if our nth root matches our exponent, they cancel. So what about number 9? Do they match? So that means they cancel, and my answer is Z. Okay. Number 10. Do they match?
Yep.
So that means they do what? Cancel, and my answer is PQ. That was that concept. Stuff that we already talked about when doing the last concept. So if they match in any way, they cancel each other out. Next concept is special cases. So for special cases, for example, this first one, square root of d plus 3 squared, we can't automatically cancel these out. Because instead of this term being a multiply or a divide, it's an add or subtract. So what does this square tell us to do? Not quite. Yes, but what does the square tell us to do? You're thinking of the next step.
Multiply those two times, how do I say this? Square root of d plus 3 times the square root of d plus 3.
Good. So what this square tells us is that we are going to write this parenthesis 2 times. So square root of d plus 3 times square root of d plus 3. So again, this square says we write it twice. What if it was a 3? We would write it 3 times. What if it was a 4? 4 times. Right here, we're just doing 2 times. So that means we have a binomial times a binomial, which means we FOIL. So we are going to FOIL and see what we get. So d, the square root of d times the square root of d is going to be what? The square root of d squared. Good. Square root of d times 3 is going to be 3 square roots of d. Okay, next part in blue. 3 times the square root of d is going to be 3 square roots of d. And 3 times 3, 9. What happens to the square root of d in the square in the first part? Cancel. So I'm left with d plus, how do we combine these middle terms? Add them. So 3 plus 3, 6 square roots of d plus 9. Is there anything that I can combine further here? No, so that means this is my answer. Okay.
And is it because it's like addition that we don't have to like rewrite it in a specific order, like having the variables first or second or last or anything like that?
Yeah, and it's also because we don't have, for example, like a d squared or a d cubed, because those would always come first. And these one, it doesn't matter the order. Okay, what are we going to do on number 12? Write it twice. So I have 5 square roots of y minus the square roots of 2 times 5 square roots of y minus the square roots of 2. I wrote that parenthesis 2 times. And that tells me I'm going to use what method? FOIL method. So 5 square roots of y times 5 square roots of y gives me what? 25y. Let's see if we could skip that step here. Does everyone understand how I got 25? Does everyone understand how I got y?
Yes.
Because square root of y squared, the square root and the square cancel. I'm just left with the y. Okay. Then I have 5 square roots of y times negative square roots of 2. So that means I'm going to do 5 times the negative, which is negative 5. And what's going to be under my square root? 2y. Okay. Next part, I have negative square roots of 2 times 5 square roots of y. So I have negative times 5, which is negative 5. And what's under my square root? So just positive 2y, because that negative went to the 5. And then lastly, I have negative square root of 2 times negative square root of 2. So negative times a negative is a, and square root of 2 squared is 2, because it cancels. So that means I have 25y. How do I combine these middle terms? So negative 5 minus 5 is negative 10 square roots of 2y. Bring down the 2. Is there any other terms I can combine? Nope, so this is my answer. What do you notice about the middle terms every time?
They're the same.
They're the same. So we could keep that in mind when we do it next time. They're the same. Okay. Okay. This one does not have that first parentheses squared. It has 2 different binomials that we are multiplying together. One has a positive and one has a negative, but besides that, every other term is the same. So what do you think is going to happen to those two middle terms? They're going to cancel out, okay? So we can skip those two middle terms. So that means when we FOIL this together, we are going to FOIL it out. But when we get to those middle terms, right away we know that they're going to cancel. So we have square root of 3 times square root of 3, which reduces to 3. Square root of 3 times square root of 3 is the square root of 3 squared, so it cancels to 3. Then we have square root of 3 times negative 2. So that's negative 2 square roots of 3. Then I have positive 2 times the square root of 3. Positive 2 square roots of 3. Again, notice, negative 2 square roots of 3, positive 2 square roots of 3. These cancel. And then our last term, 2 times negative 2 is negative 4. So that means I am left with 3 minus 4, which is negative 1. So ultimately what I did here is I took the first term times the first term. Okay, so we're going to look at 14. I did this first term times the first term. And then I did the second term times the second term. Because even though these are the same exact parentheses, the only difference is one is positive and one is negative, which means the middle part cancels out. So we don't have to deal with that middle part. We just have to deal with multiplying the first two together and then the last two together. Okay? So that means we have 1/3 square root of s times 1/3 square root of s. Okay? Minus 3/4 square root of t times 3/4 square roots of t. Notice I didn't do the FOIL method. I multiplied the first two terms and the last two terms because I knew that the middle terms were going to cancel. So simplifying this, what's 1/3 times 1/3? 1/9. Remember, we multiply the top, multiply the bottom. So this is 1/9. And what's square root of s times square root of s? Good. Square root of s squared, which reduces to s. What's negative 3/4 times 3/4? Good. Negative 9/16. And what's square root of t times square root of t? T. Can I combine these two? No, because one's an s and one's a t. So that means this is my answer. Okay. So again, these are special cases. Okay. If we have the same parentheses being multiplied by the same parentheses and the signs are the same, that means the middle terms will cancel out. And we are only left with the first two terms and the last two terms. Last concept here is multiplying radicals with different indexes. Okay, so before we said we could multiply the radicals together if the indexes were the same. In this case, we can't. We can't multiply them together if the indexes are different. So what we're going to have to do is we're going to turn these roots into exponents. So like we did on a previous notes. Okay? So that means the cube root of 5 is the same as saying 5 to the 1/3. Do you guys remember doing that on a couple notes back? turning a radical into an exponent. Times, what would be the fourth root of 5? 5 to the 1/4. Okay. We know that the properties of exponents say that if our bases are the same, which they are, they're both 5, and we're multiplying, what can we do to the exponents? Add them. So this is the same as saying 5 to the 1/3 plus 1/4. How can we add these fractions together? Common denominator. So what would be the common denominator between 3 and 4? 12. So that means we would have to multiply the first fraction by what?
4.
And the second fraction by?
3.
So that means we would get 4 twelfths plus 3 twelfths, which is 7 twelfths. So that, bringing it back to our problem, 5 to the 7 twelfths. Now we have one base with one exponent. Remember, we learned how to turn exponents into radicals. So we remember that this top number here is our exponent. And what's the bottom number? You guys remember? The nth root. And we just learned that the nth root is called the index. So that means we would write this as the 12th root of 5 to the 7th power. This is our answer. So if we have different indexes, then we need to turn our radicals into exponents. Once we have a single exponent, we can turn it back into a radical. Any questions on 15? Okay. Last one, number 16. Okay. For 16, we have the cube root of 7 times the square root of 2. So the indexes are different because one's a 3 and one's a 2. So how could I write the cube root of 7 as a exponent? To the 1/3. How could I write the 2? 2 to the 1/2. Okay. So in order to, let me think here. Okay, what do we notice about the bases? They're not the same. So can I do the same steps as I did on 15? No, they're not the same, meaning I can't add these exponents together. But I still need to be able to get the same index. So I still am going to have to find that common denominator. So off to the side, I have 1/3 and 1/2. What's the common denominator between both of them? 6. So what am I multiplying the first one by? And then what am I multiplying the second one by? So that means I have 2 6 and 3 6. So this is now becoming 7 to the 2 6 times 2 to the 3 6, because I still needed that common denominator for the indexes, because I need the indexes to be the same. Okay. So if I were to turn these separately back into radicals, since they have different bases, what would 7 to the 2 6 become as a radical?
6/7.
Good, the 6th root of 7 squared. What about the second one? Good, 6th root of 2 cubed. Okay. Now that they have the same index, I can write them under the same radical. So this becomes 6 root of 7 squared times 2 to the third. Okay. We're going to have to simplify that. So the 6 root of 7 squared. What's 7 squared? 49. What's 2 cubed? 8. Now we simplify this further. What's 49 times 8? 392. So that means this is our answer from when we multiply the third root of 7 times the square root of 2. We get the 6th root of 392. So 2 different ways. If we have the same base, we use examples like 15. If we have different bases, we use examples like 16.